The deep sea is one of the most mysterious and mesmerising places on the planet. Inhabited by bizarre creatures living in extreme conditions, it couldn't be further from our normal ideas of life on Earth. The most exciting thing about the deep sea is that there's still so much to discover. Modern technology is opening up the dark depths, and scientists are venturing further than ever before into this alien realm. Hello, I'm Helen Scales, and in this special edition of The Naked Scientists, I explore the wonders of the deep with biologist Tim Shank. I caught up with him in his labs at the Woods Hole Oceanographic Institution to find out about a pioneering research expedition he recently led to explore the deep sea around Indonesia. It's part of an area known as the Coral Triangle that's famous for the riot of marine life in shallow water. But what about the ecosystems that lurk further down beneath the waves?
A couple of years ago, we realized we really don't have any information about the deep sea there. Anything below, much below scuba diving depth, we really don't know what lives there. In that region, we know the diversity is high. We also know that there are biogeographic boundaries. And what I mean by that is if you cross this line, we start to see different kinds of species. It's kind of like seeing koala bears in Australia and kangaroos versus something else that you might see in Asia. So we wanted to know if the deep sea is as diverse and if there is this line that we see in shallow water and in terrestrial systems. So we put together a cruise. It was a couple of years in the making, because it was new technologies and new people involved. And the technologies were a brand new ship dedicated to exploration of our deep oceans. And the new scientists involved were Indonesians and U.S. scientists. And for the first time, we started a real collaboration in the deep sea. It's a 5-year-long collaboration really pushed forward by the Obama administration to bring science and technologies to countries around the world, to Islamic countries around the world. And so that's just what we did.
So you had the first trip was last summer. You mentioned that there's some new technologies. How do you go about studying the deep sea like that? What kind of kit did you have?
Yeah, the deep sea is tough to study just to begin with. I mean, normally we have deep submergence vehicles. These are submarines, like people can go in. Others are robots that are tethered to the surface, that are basically, you're able to have high-definition video cameras on board, lighting. You know, it's very dark in the deep sea. You have to have really good lighting. And then normally they have some way of sampling the seafloor, sampling the animals, sampling the rocks. That's really important. So those are the very basics. But we also have lots of other robots and things we use that some are autonomous. We can program them on board the ship. We let them go for over a day now. They can go and traverse around the seafloor, taking pictures, making maps, all by themselves. And then we would just recover them and download the data. It's really fantastic. In this case, we were doing something really novel. We had a remotely operated vehicle, so we had a robot that had a very good high-definition camera system, and we were doing pure exploration of the seafloor. No one had ever been to this area of Indonesia, north of Indonesia, in the Sulawesi Sea. And so what we did was the ROV, the vehicle wasn't novel in itself, but the signal that was coming off the seafloor was transported around the world. There were scientists in Indonesia and various parts of the United States, in Europe, that were all tuning in at the same time. We had Skype and iChat going, and as we saw live pictures come in, we could hear the pilots of the ROV on board the ship. We could hear everybody on the ship we wanted to, and we could communicate with everyone who was listening in. We had also conference calls going on at the same time. So we had voice, we had iChat, we had Skype. So that to me was a real first. And so we were able to see things in real time and say what we thought we were seeing. You know, we were all saying, okay, someone would say, what is that? And someone would say, I have no idea. Oh, that's some fish. And then, okay, well, all right. And so what we did was we documented what's on the deep sea floor north of Indonesia, and we had some remarkable results. In short, we found very high diversity. We found diversity that rivals that of the shallow water Coral Triangle area. The region we looked at was between 300 meters deep and 5,000 meters deep. So we covered a lot of different kinds of habitats, mid-ocean rift habitats, a lot of deep sediment habitats. We actually found wood and coconuts that were being used as habitat from certain species. There's lots of wood apparently that falls into the water in that region of the world, and it actually hosts a different kind of chemosynthetic community, those communities that live on decaying material. We think we found more than 40 new coral species and even more other invertebrate species. So it was a really dramatic find.
You say that we had this sort of live global lab almost with all these people, and you were in charge of this particular expedition, but you didn't actually get out on the ship.
No, actually, I didn't. I ran a portion of it from my lab. It's a 12-hour difference between my lab and where the submarine was. So we would work all day here, and then at night we'd do the operations of the ROV. And yeah, we basically command it from here. And then I actually went to Indonesia for part of it. So I traveled, and through the hotels that I was in, I would also then tune in through my laptop and not miss anything. And then got to Indonesia, and we sat there at what we call a command center. It's a lot of flat screen monitors and lots of communication devices to talk to everybody around the world. And it was fabulous to interact with our scientific partners that we haven't done so with before, and show them how we do things. They showed us how they do things, what they know of the animals, in the shallow water. It was a wonderful collaboration that we did. But yeah, I've never done that before, and I've been able to even get on your phone and check in to the expedition, and it's called telepresence, and we were there even though we weren't there.
And I believe one of the features that you found, and I don't know did you find the undersea volcano, or was that already known about?
Well, there was one that was known about, and that we had some signals from that there might be something called hydrothermal venting there. This is a superheated water that gets below the seafloor. It becomes superheated down there, and it rushes up toward the seafloor, and with it brings a lot of dissolved metals and sulfides, things that are kind of nasty to us, but there's animals that really like it a lot. And so this hydrothermal venting was suspected in a certain area on this one big seamount. But we did discover other seamounts we didn't know were there. So we did a lot of mapping. We mapped an area the size of Oklahoma, basically, on the seafloor, which is a lot. And so through that mapping and through our visual analysis of the seafloor, we found lots of species, and we found this venting area we suspected was venting, and it certainly was, and it was venting in an unusual way too. It was I mentioned that sulfides normally come out, it's dissolved into the seawater. In special occasions where you have certain conditions where it gets hot enough and cools fast enough, you actually get this molten sulfur. It's elemental sulfur. It's yellow and gray and brown, different colors, but it comes oozing out like candle wax out of the seafloor, and we've only seen that a couple of times around the world. And this one has a lot of that. It's really intrigued a lot of scientists as to why that's the case.
And you mentioned the fact that there's a lot of wood down there, which is fascinating. But there are other chemosynthetic organisms down there that are living off of these interesting chemicals that are down there on these seamounts. What's going on with those?
The seamount where we found these hydrothermal vents is called Kawio Barat, and we found clams in the outlying sediment that have bacteria in their gills that allow them to take in the nutrients and give it to the clam as the host. So it's a symbiotic relationship that allows them to live there. And so we saw lots of clams as we proceeded away from the actual vents themselves. But at the vents where the water's coming out, we saw a lot of shrimp and a lot of barnacles. These are stalked barnacles that may be 8 to 10 inches long. That they're so numerous. It's like sometimes we liken it to going through a car wash. They're on every side of these large chimneys, we call them. They're like large spires, and they love being there. They're very top. They love being up into the current where they get nutrients that come in, and they're only around these vent systems. And so we're still trying to identify what species it is. It may be a new species to us, as well as the shrimp that live there. They live there in very large numbers, and they walk right along the top, on top of the chimneys and through the water coming out, and there may be 3 species of those. We're not sure yet. It's a fantastic find. No one has seen chemosynthetic fauna or hydrothermal vent fauna in this area of the world before, and so it's new to us. The closest we have to the west from there is the Indian Ocean, which is a fair bit away, and then we have some that's in the Lao Basin, which is south of Guam. So we know some there, but this is a really sort of isolated part of the world. We now have another vent system that we found.
Very exciting. So I guess there's an awful lot we still need to discover about these habitats. There must be more questions than answers at the moment.
Oh, yeah. Every time we had a dive, whether it was shallow water or deep, we found something new. The amount of diversity we saw at 300 meters was really remarkable, and the coloration of the animals. They blended into their surroundings. Even at 300 meters where it's black, pitch black to us, they seem to be using camouflage for some reason, or they still have it. For some reason, they haven't lost their ability to have camouflage. When you go deeper, you lose that color. And when we were seeing wood at 3,000 meters, 4,000 meters, all the animals were white. They were nothing like we had seen anywhere else in the sediment or the vents or anywhere else. really remarkable. And the thing is, with this vehicle that we had, we couldn't sample, we couldn't collect them, so we couldn't bring them back to the lab and dissect them and play with them and look at the morphology. We just could take pictures and a video. And that said, the high definition video was very of high resolution, and so we were able to get in really close, and in some cases, count the little hairs on the back of the shrimp. That helps us identify who they are. And so that's what we're in the process of doing now, is identifying who all these species are. And again, remarkable diversity, so it will take some time.
Yeah, I bet. And we're still learning lots. We're still discovering so much. And one of the things about the shallow water communities in this part of the world is we know that they're extremely under threat from lots of human activities. Are there threats to these deep sea ecosystems as well?
It would seem unlikely, but there are actually many threats to deep sea communities now. And the more we look, the more we realize. We've known for some time that there were communities on seamounts that attract fish, whether it's the juvenile fish or the adult fish of commercially fished species. And so we've known for some time that trawlers will go out and rake over the tops of these seamounts, and they wipe out coral communities that we know are thousands of years old and will take that long to recover. And so it's a tremendous, actually, disturbances that we may be impacting the deep sea communities. And now we see in the Gulf of Mexico, for example, that oil can also have an impact. We're starting to see that on coral communities in the deep Gulf. Of course, we know that in the Western Pacific there are large sulfide deposits that ring the Western Pacific vent systems, and there's an intense interest to mine those areas, those extinct sulfides. And that's actually underway now. I mean, for the last, at least 5 years now, they have been surveying and doing environmental impact assessments on vent systems around Papua New Guinea, for example. First of all, you've got to learn what the animals are down there. Then you got to think about how they disperse from one site to another, and if there's other sites available. If you're going to chew up one site and rip up all the sulfides where they might be living, it'd be nice to know if there's any other places around that are habitable for them to maintain their species in those communities. And I know that some of the mining companies have gone to great efforts to sanction off or protect some areas of vent systems in nearby areas. It's really not clear whether that's an appropriate design or not, if that's going to really work. But they're partnering up with scientists that are trying to figure that out and see if those are good ways of designing protected areas in the deep sea. It's clear from our studies that some vent systems can recover very quickly from disturbance. There's natural disturbances in the deep sea. There are eruptions on mid-ocean ridges all the time meaning every decade or so, and then animals can grow fast, reproduce fast. It's remarkable, actually. But there are other vent systems around the world that are actually very slow and see very small disturbances, like the Mid-Atlantic Ridge and those in the Western Pacific. So there are some big impacts that can disturb these communities in the deep sea.
So it seems a little bit premature, maybe, that we think we understand them enough to say, hey, we can leave a protected area and that'll help fix it up, when we really don't necessarily know that by the sounds of it.
We don't know how these animals reproduce. We don't know how far their larvae travel. We don't know how long it takes to recover from a big disturbance like mining, for example. There's so many questions that I think that if we waited to get the answers, we wouldn't mine for decades. It would take that long. And I know that there's an effort there to try to get some of this information down. But the thing that we have to keep in mind too is they're mining the extinct sulfides, not the active part, right? So they're not mining the vents where the animals are really living right now in great abundance and all that. They're mining the ones that were active thousands of years ago. Now, what do we know about the animals living on those older extinct sulfides that were active thousands of years ago? We don't know much. There's only been one study ever done to know what's really living on those old places, and that's habitat for corals and things like that. But we really don't know.
You mentioned that this is the beginning. Your expedition to Indonesia
Yes.
this year was the beginning of a long-term project. What's next for that project?
Yeah, this was year one of 5, actually, and we're really looking forward to working with them more. We actually have an exchange of students that are going on now, and we're trying to get their faculty over here and whatnot. And then we have planned another cruise to the east of where we were last year. It's called Halmahera area. We think it has chemosynthetic communities there. It's not venting there, it's seeping. It's coming up through sediments. So it's not really hot. It's cold nutrients that are coming up. But we normally in those areas see clams and shrimp and tube worms. In Indonesia, in this area, there's a one-way current regime that flows. It only goes one way. It's called the Indonesia through flow. And their scientists there really want to know if that's what's happening and if the species are the same on either side of this area where this is happening. So they're trying to look for boundaries or barriers down there in the deep sea. So that may be controlling diversity. We're looking forward to it. It'll be another month and a half long cruise to there, and I know we're going to find some really incredible stuff.
Well, we look forward to finding out what they discover in their next exciting expedition to explore the deep sea around Indonesia. That was Tim Shank from the Woods Hole Oceanographic Institution in the US, talking to me, Helen Scales, about his explorations into the deep sea world and how modern technologies, including the wonders of the internet, are helping to shine a spotlight into this most extraordinary and little-known realm. You can find out more about the deep sea and other fantastic marine life at the Naked Scientist web pages that are dedicated to the sea. Every month in the Naked Oceans podcast, we bring you the very latest marine science and conservation and dive beneath the waves to uncover a different ocean topic, from seagrass to sunfish, dugongs to diatoms. You can find the whole first series of Naked Oceans, including an episode all about the deep sea. That's all at thenakedscientist.com/oceans. Thanks for listening. Catch you next time.